to talk about for the next 40 minutes to 45 minutes, I guess, is agile data warehousing and business intelligence. So how do you take a disciplined approach to data warehouses? So the story I'm about to tell, I always like to start off with the end in mind. So here's the story that I'm about to tell. So one of our issues is that we have many challenges to overcome. We'll see when we get to the presentation that the data community and the Agile community have very different ways of looking at the world. Both are valid, but they're very different, and we need to find a way to work together collaboratively and get the job done. We also, I'm going to ask everybody to think outside the box. So if you're new to Agile, then there'll be some very interesting concepts here for you. If you're new to data warehousing, there'll be some very interesting concepts for you. So, anyways, and I'm going to challenge. And if you're experienced at both, then hopefully I'm going to challenge you a bit. And I really do want to get you thinking outside of the standard Agile box, and certainly outside of the standard data warehousing and business intelligence box. Part of my message here today is discipline is absolutely essential. We need to be more effective in the way that we approach Agile, and certainly approach data warehousing. So I'm going to challenge everybody here. One of the points that I'm going to make over and over and over again, and this is particularly challenging to the data warehousing folks among us, is that modern development is evolutionary in nature. This is true for data warehousing as well as for other types of solutions. So, I think a primary message I have here today is that the data world is not special at all. Some people will make it out to be that data is special, that somehow the laws of physics don't apply, but it's certainly not true. And we'll see in a few minutes that not only can data warehousing be done in an evolutionary manner, but that it is highly desirable to do it in an evolutionary manner. We also need to be flexible. I think this can be a bit of a challenge, of course, but the Agile in particular is all about flexibility and collaboration and working together effectively. So we need to once again think outside the box a bit. And as I said, collaboration is absolutely crucial to our success. We need to work together on this. We have got to stop this this environment where the developers on one side of the fence and the data professionals on the other. We need to work together as a whole, and that means that all of us need to change the way we look at the universe and change the way that we're prepared to approach the work that we're doing. And hopefully, I'm going to convince you that now is the time to leave your comfort zone. We need to get better. We need to get better as professionals and as organizations. One of the things that I've been doing lately, and my team has been doing lately, is we've been working with organizations around the world, and in almost every one of them in the last year or so, they have all had very serious challenges on the data side of the fence. The data folks have not been agile. They've been working in a very slow manner, incredibly slow, and in several cases, putting the organization at risk in their just inability to produce and to produce value on a regular basis. Now, having said that, we also see Agilists really struggling with data stuff as well, and often increasing technical debt within their organization because of their lack of knowledge around data. So anyways, like I said, we need to work together on this. So what does this all look like? So first of all, what are these challenges that I'm talking about? Where are we sort of struggling? So first of all, now this information is from a survey that we ran about a year ago now, and one thing I should point out is that this is completely open research. This data can be downloaded free of charge from ambisoft.com/surveys. So this is completely and 100% open research. You can see the questions as they were asked. You can get the source data as it was given, and you can see our analysis. So you don't have to trust us at all. And the point that I want to make out of this is that, and as you can see, we have some rather interesting challenges, might be the polite way of saying it, when it comes to data quality within organizations. And we struggle to prevent new data quality problems, and we also struggle to fix existing data quality problems. Now, to be fair, as you can see, there are some organizations that are fairly capable at addressing data quality problems, so good for them. But you know, the vast majority of organizations are clearly struggling. So there's room for improvement here. We need to get better, and I think, and actually my experiences are that the organizations that are struggling with data quality almost always are struggling with fundamental issues around a lack of agility on the within their data approaches, within their data management strategy. So anyways, we'll see what that looks like in a bit. We also suffer from what's called a cultural impedance mismatch. So the point of this slide is that you know, if we were to go back in the past, say 30, 40 years ago, the developers and the data professionals were basically following the same paradigm, this traditional serial approach to software development, to working in general. And you know, we're following this waterfall life cycle, and it all worked out. You know, we were reasonably well aligned in our priorities and our preferences for working. And then in the early 90s, and you can argue, and I don't want to, but you can argue when the object revolution actually began in the business world, but for the most part, it was early 90s. And this is where the impedance mismatch, or the schism, came in. So what happened here is organizations started adopting object technology. You know, they were adopting Smalltalk and C++ and good stuff like that. And the data community generally didn't. You know, they viewed the world in you know, from the perspective of databases, and to be fair, they nailed it. You know, they were very skeptical about object databases and whether or not they would take off, and as was I at the time. But they were right. Object databases were never more than a niche technology, but they didn't see the big picture. They didn't see that object technology was far more than just object databases. And as we all know, object technology took off and is frankly the norm in many organizations now when it comes to software development. And this is where this impedance mismatch started to come about. And then in the early 2000s, when the Agile Manifesto was published, we saw an even greater difference in outlook and in viewpoint. So the developers started really getting serious about working in this iterative and incremental manner. And to be fair, they were very serious about, reasonably serious about it in the 90s, but certainly in the 2000s, they became very serious about it. And they became serious about working more collaboratively in a lightweight manner, in a test-driven manner. We'll see the implications of that in a bit. So the differences between what the development people were doing and what the data people were doing became even bigger. It became more and more difficult to work together. It became more and more difficult to even communicate and to share values. You know, we're seeing similar things in the political spectrum out there these days. So, you know, our organizations clearly suffer. Now, the good news is that in the last couple of years, I have been seeing a greater understanding and appreciation for Agile database strategies, at least within the data warehousing community. And I think we've been seeing a bit of an uptick in adoption of this Agile stuff within data warehousing folks. And I think the reason why is because one of competition and one of having to, of time to market, having to be able to deliver faster and having to be able to actually deliver more effectively and produce solutions that actually meet our stakeholders' needs. So I think that the pressure has been put on the data folks finally, and they're starting to respond. So this, I think, is great. So we're now, will we ever close the impedance mismatch gap? I don't know, but it's certainly going in the right direction, I hope. So we'll see that as it is. So what are some of the differences? So in the traditional world, there's this belief in documentation, this belief in heavy modeling, and particularly heavy modeling up front. So we'll often create detailed logical data models, detailed physical data models. We'll start capturing detailed metadata. There's a lot of specification going on. There's a lot of modeling documentation. This is slow. This is risky, and it's expensive. And I think that this is one of the primary sources of frustration. I think with with the way that data professionals currently work is that it's just so slow and so expensive, and the results aren't very good. We struggle sometimes to respond to changing requirements. We struggle to get things out the door, time to market, basic issues, and even the quality isn't quite there. We'll see. We saw some data just a few slides ago around that we really sort of struggle when it comes to data quality. So the vision of the traditional approach simply isn't working. We can see these results in organizations around the world, and we do see these results in organizations around the world. And we've given it several decades now. You can argue that we've been trying this since the late 60s, early 70s, and frankly, it's not working out so well on average. So we really need to do better. So how do you take a discipline agile approach to data warehousing and business intelligence? So the discipline folks, we still do a little bit of upfront modeling, but it's lightweight and it's streamlined. So we'll often capture high-level models. We'll often do sketches as opposed to detailed case-based models. So we're a little bit smarter about this, and we also trust that we can capture the details when and if we need the details. So I think that's a different mindset. Whereas in the traditional world, they try to capture the details up front and think everything through for the most part. In the Agile world, we don't try to do that. We see that as phenomenally bad practice, and we see that as risky and expensive and slow. Another primary difference, which I think you can hopefully catch on to, is the testing is far more important in the Agile world than what we see in the traditional world. So I'll just go back a slide. We can see that very little effort gets invested in database testing in the traditional data warehousing world. And in many of the organizations that we've been working with lately, very often the data teams haven't even thought about testing. It's not even barely on their radar scope. If they've even thought about it at all. So this is a bit of a challenge, whereas in the Agile world, testing is a first-class citizen. It's absolutely critical to our success, and it's so critical that we do it all the way through the life cycle, and we invest in regression tests for everything that we do, including database work. So I think this is a very interesting thing to observe, and as a result, we can get away with far less specification. And what's really going on is our tests form our detailed specification in many ways. So, and there's tools and techniques that we can apply to pull that off. So we'll review that in a bit as well. So this requires a culture change. I think the biggest struggle that I see in most organizations these days when we're adopting Agile is around culture, is around the people. And this is particularly true in the data world. And because of the impetus mismatch, it's hard enough helping traditional developers to adopt Agile techniques. There's enough of a culture shift there that it's a bit of a challenge. But in the data world, it's even worse because of the greater distance that most data professionals need to now traverse in order to catch up with modern software engineering strategies. So and as we know, for anybody who's been involved in transformation, it doesn't have to be an Agile transformation, but any sort of a transformation at all, is that these people issues take a very long time to overcome, many, many years in some cases. So we have to be patient. We have to understand that this is going to be a long-term investment, that we're really embarking on a journey, and we're not really aiming for a destination. We're aiming for a journey in our Agile transformation. So this can be a bit of an issue in organizations that are desperate to pick these strategies up quickly. So discipline, I believe, is essential. So what does that mean? So I'm going to walk you through how to apply the Discipline Agile delivery framework in the context of a data warehousing or business intelligence project. So several of the key characteristics of DAD, which may be a bit different for some of you. It has all the good Agile and Lean stuff where it's people-oriented, it's very learning-oriented as well. We explore the requirements on a just-in-time basis. We work through the design on a just-in-time basis. We're constantly trying to improve, constantly trying to experiment and learn. We take a goal-driven approach. We'll see the implication of that in a bit. The idea is that every team, every person is unique, they find themselves in a unique situation. So as a result, they need to tailor their approach to meet the needs of the situation they find themselves in. So clearly, a data warehousing team will work differently than a team building a website, than a team building a mainframe system. So different teams in different situations will work in different ways, and that's okay. The Discipline Agile framework is a hybrid. It takes ideas from a very wide range of sources, including Agile sources, Lean sources. We adopt ideas from Scrum and Agile modeling and extreme programming, and we'll see some of these techniques in a few minutes. We adopt ideas from the Lean community. We adopt ideas even from the Unified process folks, and even the Scrum folks. So there's a lot of opportunities for, there's a lot of great ideas out there in the process world. And we help. One of the things that we do in DAD is we put them all together. We show how everything fits together from beginning to end, and we help guide you through these process-oriented decisions that your team is making on a regular basis. We're also enterprise aware. I think this is absolutely key in the data world, is understanding that your team is only one of many. That we should be doing what's best for the organization, not just what's convenient for the team. And clearly, data should be a corporate asset. And frankly, data warehouses touch on almost all of the data within an organization, or at least all the data sources. And we get to see the complete dog's breakfast that our data sources are in many ways. So the data warehousing folks always run into the serious data quality problems because we access most of the key data sources in the company. So we get hit from all areas. Okay, so one of the things that we do in Discipline Agile is we go beyond delivery. We go beyond software development. We're one of the few frameworks that do that. And so in Discipline Agile 2, we look at, we basically ask the question, what does an IT department look like? What does an Agile or Discipline Agile IT department look like? So, so how does enterprise architecture fit in? So how do we maximize the flow or streamline the flow throughout the entire IT effort, not just software development, not just DevOps? So how does portfolio management, how does reuse engineering fit in? How does DevOps fit in? And how does data management fit in? I think data management is absolutely key. So if your organization believes that data is a corporate asset, and I hope you do, then that tells you that your data management folks, your data architecture folks, your data professionals need to work with the development teams. They need to work with the rest of the IT organization, within the rest of the business, and do so in a way that reflects how we work together as a team, not just what's convenient for the data people, but what's best for the organization. And similarly, the development teams also need to work in that same sort of manner. They should be doing what's best for the organization, not just what's convenient for them. So everything's got to fit together. We need to look at the whole, not just the parts. So I think that for many years has been a huge struggle. So continuing on here. So as I mentioned, DAD is the Discipline Agile framework is a hybrid. We take ideas from a wide range of sources and we show how they fit together. So in many ways, Discipline Agile is the mortar between the bricks. We provide advice for when to use a technique, when not to, how they fit together. To what extent should you use them? In what situations should you use them and not use them? So one of our philosophies is that there's no such thing as a best practice. All practices are contextual in nature. So any given practice is good in some situations and is a phenomenally bad idea in others. So as a professional, how do you determine when to follow a practice, when not to what extent to follow it? So this is what the Discipline Agile is bringing to the table, where we have this bird's eye view. So one of the observations that I mentioned earlier is that every team is unique. And as a result, every team should work in a manner that reflects the situation they find themselves in. So one process size does not fit all. Not one life cycle does not fit all. So one of the things that we bring to the table in the Discipline Agile framework is we support multiple life cycles. We actually support 4. Now, 2 and maybe arguably 3 are applicable to data warehousing and business intelligence situations. So let's talk about that. So one of the observations that we've made over the years is that for the first release, or at least the first Agile release of a data warehouse, you're more than likely better off to follow what we call the basic Agile lifecycle or the Scrum-based lifecycle, and we'll do a quick review of what that looks like in a minute. But once the data warehouse is up and running, once you've got something in production and it's being used, then you're much better to switch over or to evolve into more of a lean life cycle, and better yet, a lean continuous delivery life cycle. And for a couple of reasons, but for the most part, it's the nature of the changes that you get with an existing data warehouse. So once a data warehouse is up and running, the types of changes you get are typically, or asked for, I should say, are typically best addressed through small quick changes. Adding a new report, or adding or adding a calculation or a calculated field on an existing report, or adding a new reporting table, things like that. They're very reasonably small changes that can often be done in a couple hours or a few days. So let's do this work and then get it out the door as soon as we possibly can. We shouldn't have to force our end users to wait for a quarterly release or a bi-weekly release because we're following 2-week-long sprints. So anyway, so we can be a little bit smarter sometimes about our life cycles. That's what we're getting on this slide. So as I said, so we in Discipline Agile Delivery we support 4 different life cycles, four different delivery life cycles, I should say. One of them is the basic Agile life cycle, the Scrum-based life cycle. So this is what a Scrum-based life cycle looks like when you look at the effort from the beginning of a project or the beginning of a release all the way to the end. One of the things that we do, if you're new to Discipline Agile, one of the things that we do is we're not afraid to use Agile swear words like phases. So we have explicit phases: inception, which is like a startup phase, sometimes called sprint 0, a construction phase where you build or configure your work, and then a transition phase where you release into production, or you release into the marketplace. As you can see, we also have common milestones and many other things. So this sort of a life cycle, as I said, is very applicable to a team that is working on the first release, the first production release of a data warehouse. So you typically are better off to work in these short iterations or sprints, and then iteratively and incrementally build up the solution over time. But once you're in production, you're more than likely to follow your better advice to follow a lean life cycle. In this case, this is a lean project-oriented life cycle, or better yet, a lean continuous delivery life cycle, where if you keep your team together, when you keep your team together, what you'll find is that inception basically disappears because we no longer need to do the startup stuff. Transition starts to disappear because we automate everything. So where transition on an Agile project team is on average 4 weeks, when you keep your team stable, when you allow them to get better, find ways to work better, when you make them responsible for doing releases on a regular basis, which is highly desirable for your stakeholders, it motivates them to automate the living heck out of transition. So they have full automated test suites, they have fully automated deployment scripts. If they release more often in production, they have less testing or less training, if any, to do. They have less communication to do with less work to communicate the upcoming release, and so on. So by shortening the feedback cycle and through one heck of a lot of automation, you can shorten your transition phase from a multi-week effort to a multi-hour or multi-minute effort. So these organizations, if you've done any reading in the DevOps space, you'll hear about teams all over the world in many different situations in a full range of business sectors, who are releasing into production several times a day, or at least several times a week, and thinking nothing of it. And it's because they're very good at what they do, but also they've chosen to automate everything and make difficult things like releasing, like deploying into production, to be simple through automation and through just better release management practices. So anyway, so having said that, so the point is that Discipline Agile supports several different types of life cycles in order to support different ways of working. So in this section, I'm gonna very quickly work through some principles of working for Agile DW, Agile BI. Okay, so first of all, Agile DW BI is highly collaborative. We work together in teams. hopefully side by side. So the top picture is this a medium-sized co-located team working in a regulatory space, as opposed to people working together by themselves. In the bottom picture, we see a gentleman or a bunch of people working in their own little cubicle areas. Presumably, that gentleman's working on whatever he's building, and then he'll work on his asset or his artifact for a while, and then throw it over the wall to the next person who then does their part, and so on. So it's a very risky and expensive way of working. This over specialization of skills that we see in many organizations. Agile, this is something that's non-intuitive at first, but Agile DWBI is usage-driven, not data-driven. So data is a secondary concern on a data warehousing project. It's not a primary concern, which is obviously, it sounds very strange considering it's a data warehouse. You would think that data would be, a primary concern. But what the observation is that what we want is, the goal here with a data warehouse or a business intelligence solution is to answer questions, to support decision making, to provide information to people in a timely manner. But we need to understand how people are going to use this information. What answers are they trying to get? What decisions are they trying to make? How are they going to use this information that we present to them? And if we don't understand the usage, then we're pretty much out of luck. A very common problem in the data warehousing world is the build it and nobody comes anti-pattern. And the basic idea is that the first release of a data warehouse is at risk of not being used or being underused. And the general problem is that the data warehouse often has wonderful data. It has the great data, often built to specification. But when people see the solution, it's not what they want. It's some of the data is not there, or a lot so the key information they need hasn't been delivered yet. So they're underwhelmed by the first release. And I believe my experience is that and I've seen this over and over and over again, is that the problem was that the team focused on the data, on what data do we need, what data can we get. That's a fundamentally flawed question. What data can we get? Let's clean it up and dump it into the data warehouse, as opposed to what data do we need? How are we going to use the information? How are we going to answer decisions or answer questions? And this is a very important nuance. So in the Agile world, we take what's called a usage-driven approach. So we create user stories or use cases or scenarios. Like 99% of the time, it's user stories. And what we want to identify is how the information is going to be used, not what the information is. So it's a very important nuance that I find many data professionals struggle with, at least at first. Agile DWBI is evolutionary in nature. It's not traditional. It's not serial. So, for example, what we're getting at here, and this is anybody used to Agile with Agile experiences has seen this diagram before. So the basic idea is we try to get a small release out as quickly as we possibly can. So in this example, our stakeholders need to get from point A to point B. So yeah, we could model the living heck out of it. We could get some great analysts, and they can go out and gather requirements, and we have great architects figure out how to build it, and great people to build it, and eventually we could deliver a racing car if that's what people asked for at the beginning. Or we could step back a bit and say, well, wait a minute. Even though you're asking for a racing car, what's your real goal here? We want to get to point A to point B. So let's do the minimal amount of work that we can do to provide some real value, and then get something out the door and see what people actually want. See how people use it. See what's useful to them in practice. So in this case, let's build instead of giving them the racing car they asked for, let's provide them with a skateboard. Is it a perfect solution? No. But you know what? It can help them get to wherever these short distances a lot quicker. And then we realized, well, wait a minute. Yeah, even though the skateboard did help, it really wasn't the best solution. And we start thinking about it a bit more. Maybe this little scooter thing will be better. So we get that out the door pretty quickly. And then we realized, well, wait, this foot scooter is great, but we really need a motorcycle or some sort of a electric scooter. In this case, I guess it looks like a Vespa, and because we have greater distances to go, we need a little more speed because we're really in the pizza delivery business right now, and we it's better to deliver pizzas on a motorized scooter as opposed to a foot scooter. And then our needs change. So the Vespa works for a while, and then we buy a new house and we realize, I need to go to Home Depot a lot or Lowe's and pick up 8x4 sheets of plywood and boards and all that good sort of stuff. So the problem is, and the Vespa's no good, and what we really need is a pickup truck. So we work our way into a better solution while constantly delivering real value to our stakeholders. Whereas we could have spent a lot of money building this race car, only to discover that we ended up with a really great race car, but it's completely utterly useless for carrying 8x4 sheets of plywood. So yes, we can deliver pizza in a Ferrari, but we look a bit goofy doing it, but we can do it. But we certainly can't do home improvement using our Ferrari. So we would spend a lot of money, maybe had a really neat solution, but it doesn't actually get the job done. So this is what it's all about. Let's be smart. Let's be practical about the way we develop our solutions. So these Agile teams work in short iterations. 80% of Agile teams work in iteration or sprint lengths of 2 weeks or less. So every 2 weeks, we have new working functionality that we could potentially ship into production. And this works from end to end. Teams around the world have been doing this, including with data warehouses. So the idea is at the end of our sprint, at the end of the iteration, if our stakeholders say, wow, you've done a great job, you should please deliver this into production now, I want to start using it right away. The answer should be yes, we can deliver it this afternoon, or we can release it this weekend, or maybe in a day or two after a little bit of cleanup. The answer should not be, well, we got another 3 months of testing and fixing, and eventually maybe we'll get it out the door, second quarter of the year. That is not an appropriate response if you want to be competitive in the marketplace. Another thing, this could be a bit of a heartache and very difficult. I'm not saying this is easy, at least politically difficult. We should be trying to fix our data. We shouldn't tolerate poor quality data sources, even when you don't own the data source. This is the big challenge for the data warehousing teams, is they often don't own the source databases, so are in almost no position to fix the data. But the idea is that at some point your organization needs to step up. You need to start dealing with your data quality problems. And part of that is you need to fix them. We'll talk about how to fix them in a couple minutes. But instead of putting an ETL Band-Aid over poor quality data, so the transformation part of ETL is a Band-Aid in my mind. You've got quality challenges in the operational data source, whatever that happens to be. And instead of fixing the source, what you do is you instead do all this work to transform the source, to clean it up, so that way you've got reasonably clean data going into your data warehouse. So that makes sense, but it's a Band-Aid. You're not solving the real problem. The real problem is the poor quality data source. So let's fix it at the source. The real professionals, real disciplined Agilists will fix the data problems at the source. Because if you've got data quality problems, if they're affecting you, the data warehousing team, they're certainly affecting any application that is also using that operational data source. So we have all this transformation code written, all this huge overhead to cover up data quality problems. Well, let's actually address the real problem, which is data quality. So this is why we need a technique called database refactoring, which we'll review in a few minutes. And we need to be pragmatic. So I've seen some, it's been getting a lot better in the last few years, but 5-10 years ago, I'd see data teams that were desperately trying to get to the one truth. They were trying to have one master data source for the client information and good stuff like that. And that's a wonderful idea in theory, but in practice, it's virtually impossible. So in this case, in this example, we see that Bob Smith is being stored in 4 different locations in 4 different ways. So first of all, in most organizations I work in, if client data is only being stored in 4 locations, we can pretty much call that a win. But in this case, we clearly have some data consistency problems. We should fix them as best we can to the level of risk that's appropriate. But trying to have one perfect data across the board isn't realistic. So we constantly want to be getting better. We constantly want to be improving our data quality. But will it ever be perfect? Probably not. But can it be better? You bet. So a modern development is evolutionary in nature. So what does that look like in the data world? So in the I like to talk about something that we call the Agile database technique stack. So the basic idea here is all of these techniques are critical in a data warehousing BI world. So let's walk through these techniques one at a time. Oh, and by the way, if you haven't been doing so, if you have any questions, because we're going to leave time for questions at the end. If you have any questions, please put them in the chat window, so that way we can address them later on. So anyways, just thought I would point that out. Okay, so anyways, so let's get into it. So vertical slicing. This is absolutely critical. So instead, and this is at the heart of the difference between the traditional mindset and the Agile mindset. So in the Agile world, we build every 2 weeks. So if we're taking the Agile, following the Scrum-based life cycle, every 2 weeks we're going to deliver more potentially consumable solutions. So in this case, we'll be delivering new data into the data warehouse. We'll be delivering, or into a data mart. We'll be delivering a new report or a new section of a report, or updating a calculation, or adding a new calculated field. We'll and this works from end to end, from the glass all the way down to the database. And this is something that, this is functionality that could be potentially shippable into production. Now, at the very beginning of a project, yeah, this is pretty hard. You might not have access to all your data sources yet, or at least you haven't figured it out. You might not even have your staging database set up yet. So yeah, this can be hard. But you know what? You can still find ways to produce potentially shippable software, or better yet, a potentially consumable solution every 2 weeks, even in the data warehousing world. Now, some of the slicing strategies we can follow, it could be, if we are just getting the effort up and running, it could be that in the first 2 weeks of construction, we might only be able to get a single data element out of a single production data source, and get it all the way through our ETL process and our staging process, and get that into our data warehouse and into a data mart. That could be one single element from one single data source. That could be the best we could do in a 2 week period. But once we're a couple months into the project, where we've got all the infrastructure set up, we've figured out how to access our production data sources, we've got a better handle on what they actually have, as opposed to what we've been told they have, what they really have. Those can be two very different things. But so once we're a couple months into a project, then I fully expect that in a 2 week period, we should be able to add a couple reports. We should be able to add new columns to existing reports. We should be able to add new tables into our data marts, like different views on the data. This is completely and utterly realistic if you have a cross-functional team of people who are collaborating together effectively. If you have a group of specialists who hand off models and documents to each other, yes, it'd be very difficult. So let's solve the real problem and build cross-functional teams of people that can get the job done. So our first strategy is to build vertical slices of our solution. Now, to pull that off, we need a couple things. First, we need to have a clean architecture. So this is a very high-level architecture diagram for a data warehouse. So you should have be able to drop data into a staging area, then have a reasonably normalized or highly normalized data warehouse, and then a bunch of very denormalized data marts or info marts, whatever you want to call them. And so, as I said, this is a logical diagram, and then from that, your BI tooling accesses the data warehouse and/or the data marts. So this is pretty high-level stuff. This is data warehousing 101. But the fact is, I run into organizations all the time. I was recently working with an organization where they didn't have this. They'd basically taken a Kimball approach, and they were building the data marts from the ground up. And be that as it may, but anyways, they struggled with, they were seriously handicapped by their existing architecture. So they're going to spend the next couple of years refactoring out of it. At least I hope they spend the next couple of years refactoring out of it. So we'll be helping them with that, I think. We also need clean database design. So in order to easily add new vertical slices into our data warehouses and data marts, we need to have a clean database design to begin with. And if you don't, then you've got to refactor it and fix it. So the best strategy I've ever seen when it comes to architecting and designing a data warehouse is the data vault approach. So yeah, all these techniques I'm talking about today, they'll work with a Kimball approach, they'll work with an Inmon approach or a roll your own type of a thing. But I really do want to point you, if you don't know about data vault, I highly suggest you start looking into it. It's very practical. It's based on real world experiences in very complex situations. And they're very, the people behind it, Dan Lindstedt and a few others, very smart, very experienced people who know what they're talking about. So I highly suggest you take a look at Data Vault. So anyways, so here's your typical Batman and Robin joke. So one of the cultural challenges that we find in the data warehousing world is the traditionalists believe in heavy modeling up front, whereas that's actually phenomenally bad practice. Particularly in the Agile world. So it's just too risky. Yes, we definitely do need to do some upfront modeling, but it's lightweight and high level. It's not heavy and detailed. So that's the fundamental difference here. So the goal early in the effort during the inception phase is do enough modeling to get going in the right direction. But during construction, we can gather the details that we need when we need them. There's no rush to do this stuff up front because the requirements are going to change. So any upfront work based on requirements that change is a wasted effort. You've added cost and risk into the project needlessly. So it just doesn't make sense. So we want to be in a position where we can support change easily, and we want to be able to react to new ideas, to new needs, and to do so accordingly, which means we need to be very lightweight in our approach to modeling and documentation. So how does that work? So I led the development of the Agile modeling and the Agile data method in the early 2000s, and it was based on practical, empirical observations of how teams are successfully go about modeling and documenting on projects, including Agile data modeling. And so the idea here is, as I said, during inception, we do some high-level requirements modeling, some high-level architecture modeling. We want to get going in the right direction, but then there's techniques and strategies that we can use throughout construction to gather the details. So that's absolutely critical to our success. So yes, we still need to gather the details. We still need to understand what the requirements are. We still need to figure out how we're going to design things, but we don't need to do it up front. We can defer gathering the details. We can defer making decisions to the most responsible moment, which is almost always just before you're about to implement. So this is a very different mindset that we see amongst Agilists as compared to traditionalists. So we can only model in this agile evolutionary manner if it's easy to evolve our database schema. So if we can't change our database schema, if we can't change a production database schema easily, then modeling in an evolutionary manner doesn't make any sense at all. So how do you do that? So many people think that evolving a production database is hard. And the reason why is because of coupling. Everybody knows that this database is being accessed by 100 different applications, running on 100 different servers, on 100 different platforms, owned by 100 different teams, right? Or more. Hundreds. 100 is bad enough, but it could be many, many hundreds. And we know that if we just blindly make a change to database schema, then we're going to potentially break 100 apps, which people don't appreciate. So we've got to be smarter about this. So one of the philosophies in the Agile community is that if something is hard, figure it out. Do it more often. Try to make it easy. So in the early 2000s, several people, myself included, did exactly that. We realized that we needed to be able to change database schemas. It wasn't acceptable that database schemas were hard to change. This didn't make any sense to us, and this would kill our organizations if we couldn't figure this stuff out. So we went about figuring it out, and so we started looking around for techniques. So who else is dealing with this problem or worse? And what we noticed was that Sun Microsystem had this very problem with the JDK, the object schema of Java. And so Sun had several order of magnitude worse problem than any organization that I've ever worked in, because they had millions of Java programmers out there using the object schema of the JDK, but to be competitive in the marketplace, Sun needed to evolve the object schema and do so in a way that didn't break the millions of apps that were written in Java. So they introduced something called the deprecation strategy in Java. And the basic idea is that when they want to evolve the object schema, what they do is they deprecate the old schema, what they're about to replace. They put the new schema in place, the new functionality, whatever that happens to be. And then And then what happens is they release it into the marketplace. So the old stuff still works, but it throws warnings. And it throws deprecation warnings, and that tells all Java programs in the world, okay, stop invoking this stuff and start invoking the new stuff. And then several years later, then they drop the old schema, the old object schema, in favor of the new stuff. So this is the approach that we took with relational databases. So if you want to refactor a relational database or a network or hierarchical database, it works pretty much the exact same way in those environments too. What you do is you keep the old schema up and running. So in the example that we see here, what I want to do is rename the fname columns. It's just an absolute trivial change. So a trivial thing should be trivial to do. So what we do is we know that if we just blindly rename fname to first name, which is what we want, we're going to break every single app that accesses fname. So don't do that. So instead what we do is we leave fname in place. We introduce the new column, in this case first name. We copy, make a copy of the data into first name. So that way both fname and first name have the same data. And we put a trigger in place to keep them in sync because the database needs to protect itself. And then what happens is we then announce to the world, to all these application developers, that okay, we're deprecating fnames, so stop using this and start using first name. And then we give them a time. This can be several years because it takes time for people to rework their apps and release them into production. After a few years, and as an organization, you'll figure out how long it's going to take, and if you're smart, you'll monitor your databases. But after a few years, we then drop the old schema plus the trigger that we put in place in order to keep them open sync. Now, so this is pure brute force. There's tools that can do this now. By the time we wrote the database refactoring book, there's no tools. Everything had to be done by hand. And but it can all be done. It can all be done by brute force. So in the refactoring databases book, there's 65 database transformations or refactorings, and with full source code. So it is in fact possible to change existing database schemas that are highly coupled to the rest of the universe and still do so safely without breaking things down. So it is in fact possible to do. And I would, if you don't believe me, I would invite you to pick the book up. So if you've got the amazing ability to type in code from a book, you can evolve an existing database schema too. It really is that simple. So it's possible, but in order to, and that's what this book is here all about, in order to pull off database refactoring, we need to be able to do regression database testing. So if you don't have because you need to be able to figure out if you broke something, because it's not a perfect world. So just like when we're refactoring code, the only way we can safely refactor code is if we have a regression test suite in place for it. Well, we need the same thing for our database. So now it's interesting that a lot of organizations talk about data being a corporate asset, but very few actually treat it that way. Only a small percentage of organizations have regression test suites in place for their databases. So this is a very serious challenge for the data world, and for many organizations is that we're going to have to spend the next few years actually investing in our data sources and making them safe and making them safe to work with. And the only way we can one of the ways we can do that, one of several techniques we need to do, is to start putting regression tests in place for it. So this slide is getting at the point of how do we do database regression testing, or what do we need to look at when we're doing regression testing. So if you drop by the Agile data site, agiledata.org, there's a lot of information about that. And we're starting to see a couple books. There's a good book called Test-Driven Database Development by Max Guernsey III. There also, if you're in Germany, there happens to be a data warehousing testing book now published by TDWI. I don't believe that it's been translated into English yet, but frankly, testing and quality in general is truly a blind spot in the data community, and testing is as well. So I think that most of the data quality problems stem from a lack of testing and a lack of ability to refactor, or a lack of belief that it's possible to refactor. So anyways, the techniques are there if you choose to adopt them. And we're starting to see better database testing tools, although it's still early days. Many of the vendors are struggling with this concept as well. Like I said, this is a huge blind spot. For those of you in the Agile world, if you're used to doing test-driven development, so you're some of the more disciplined people, it is in fact possible to do test-driven database development as well. So as I said, Max Guernsey wrote a book on that a few years ago, and I've written for IEEE software on this topic, and there's good stuff on the Agile data site. So anyways, the techniques are out there. But in order to pull off database regression testing, you need to have continuous integration in place. So to do that, so continuous integration in the database world is a bit different because databases have data. They have persistent information. So our tests, so we have a danger in our tests. When we run a database test, it might not put the initial state back to what it should be. There's potential side effects in our tests. So the implications, every so often we basically have to smoke our database, our testing database, and reset it from scratch. This is so continuous integration in the database world is slightly more sophisticated because of the need to reset the database every so often to put it into a known state, just to be safe. And in order to pull off continuous integration, we need to do configuration management. So all of our data assets should be put under CM control. So just to wrap up here before we spend a few minutes on questions. So the story I told. So I think we've seen that there's many challenges that we need to overcome as a community. We have cultural challenges, we have skilling challenges, and in some cases we even have tooling challenges still. Hopefully I got some of you thinking outside of the box. I shared no theory today. All these techniques that I talked about work in practice. Now, obviously, I quickly reviewed them. Particularly some of the Agile database techniques like database refactoring and testing, they're worthy of a multi, at least a day, if not a several-day workshop all by themselves. So we very quickly reviewed a bunch of techniques, but they all work. And they're all doable, and people are doing them. So in practice, in very large organizations, in very complex situations. I would invite you to look into them. Discipline is absolutely essential. We need to go beyond what we see in the Scrum community. We really do need a full delivery lifecycle. We really do need to focus on choice, and we do need to be enterprise aware. I think that one of the strengths the data folks generally bring to the table is they generally have a better understanding of enterprise issues than developers do, although it's almost always narrowly focused on data and not the overall picture. But anyways, at least it's a step in the right direction. So that's a good thing. Modern development is evolutionary in nature. We are not working in this serial way anymore. So for the data folks among us, traditional serial development is no longer acceptable. It's just bad practice. Just a bad idea, and it's not required. There's nothing special about data warehouses and BI solutions. You can in fact work in an evolutionary manner if you choose to. All the techniques exist, and they work better than the traditional stuff. So it's a choice. We need to be flexible. We need to start thinking outside the box. We need to work in a collaborative manner. We need to realize that our assets will evolve over time, that we need to adopt new techniques, all that good sort of stuff. We need to collaborate. So these Agile DW teams desperately need data professionals who can work in an Agile manner, in a flexible, collaborative manner, and they desperately need developers who can bring their technical skills, particularly around refactoring and testing and other good things, in order to flesh out the team. So hopefully I've gotten you to think outside the box, to hopefully leave your comfort zone. The only way you're going to learn, the only way you're going to get better as a professional is you need to be uncomfortable. You should be constantly pushing yourself to try new ideas, try new techniques. It is possible, and it's highly desirable. So thank you very much. Let's take it to questions.
Hi, Scott. We have quite a few questions.
Okay, fantastic. What I'll do is I'll answer one or two of them, and anything I don't get to, I will respond with a blog, and we will send out an email in a day or two, and with a link to the blog. But anyway, so shoot, give me a question or two here.
So yeah, that's the time for our presentation. Questions. We'll stop the recording.